All right. But now, what I haven't said anything about yet is the M quantum number here. All right, and again, we've got a code for this. We're actually not going to use the number M. We're going to use some letters. And the code is that when M is equal to 0, we're going to put a Z subscript here on this p orbital designation when M is equal to 0. When M is equal to 1, hey, we're going to put an X subscript on this p designation. And when M is equal to -1, we're going to put a Y subscript on this designation. Okay? Now, I should tell you that what I just did here is not actually correct. All right? In other words, M is equal to 1 isn't really the X subscript, and M is equal to -1 isn't really the Y subscript. The reason is because these two P wave functions, when M is 1 and M is -1, hey, they're complex. They're complex functions. And what we do is that we do some linear combination of the M equal 1 and M equal -1 wave functions to get what we call the Px wave function and the Py wave function. One is a plus linear combination, one's a negative linear combination. You're not responsible for that. Therefore, you're not responsible for knowing when M is equal to 1, we have an X, and M is equal to -1, we have a Y. You are responsible for knowing when M is equal to 0, you have a Z subscript here. Okay? Okay, now, I should make one other point here. And that is, you see, I don't have a subscript here for M on the S orbitals. Well, in an S state, when L is equal to 0, there's only one possible value of M, which is 0, right? And so we just leave out that subscript. We don't put a Z here on the S designation. Okay?